Howdy y'all, it is Ms. Kosh and we are looking at trig transformations. This is the second video of the style I'm trying to teach this in this year, so we'll see how it goes. This is for AP PreCal and my IB math classes. So go back and watch the first one so you know what I'm talking about. The variables A and B are now multiplicative transformations, okay? And so I have on this page the three different shape trig functions that we might see, and I have an A value out front. We're going to talk about what that does for us. And then we're going to look at what happens when I change my B value for those three. I did sine on one and cosine on the other, but they have the same shape, and so they behave in a similar way. Let's jump in. Okay, so what we know about transformations is that if I have a negative out front, it's going to be a reflection over the x-axis. And the 2 is a vertical stretch, or a vertical, let's use the word dilation. A vertical dilation of 2. So my zeros will stay the same. But all of anything that was 1 here, for example, is now 1 multiplied by -2 is now -2, which means this goes down to here. And then a -1 times a -2 is a +2. And so we're looking at something like, let's see if I can draw this correctly. Okay, we're looking something like this. It doesn't work if you don't make the sound. Okay, that looks kind of, anyway. Try not to be too linear. I got a little linear there, and I'm sorry. Okay, did it change my domain? No, my domain is still -infinity to +infinity. My range, it did change. We stretched this, so now I have a range from -2 to 2, and that's a difference. Did my period change? Well, notice, let's do green. It took me still, that was one period of my graph, and that was this right here. I don't know if you can see it. It says 2 pi. Okay, so it's still 2 pi. The amplitude has changed now to 2. Notice this right here with the sine graph, the absolute value of A will equal my amplitude. That is important to know. And, okay, so that's probably what I wanted to write over here. Absolute value of A is equal to the amplitude. The asymptotes, nope. The midline, none of that changed from before. It's still y equals 0. The zeros are all still in the same place. We just pulled things away. We stretched things away from the x-axis. Okay, let's see what happens when we have something like 2 cosecant x. So does this change my domain? No, it's still the set where theta is not equal to pi k. You may remember I technically should have said, here I'll write it correctly once on this video, it's the set theta such that theta is not equal to pi k, where k is an element of the integers. That's the whole thing, but in the future I'm going to go a little shorter and I'm just going to give you this part, okay? But I should say the whole thing every time. Okay, my range will change. The period is still 2 pi. The amplitude, there is still no amplitude. We still have asymptotes where theta is equal to pi k, kes. The midline stays y equals 0. But what happens here is that this value of +1 gets stretched to become 2, and so it's going to open up something like this. This -1 right here goes to -2 and does something like this. Okay, pretend I can draw. So what this did is it made the gap. So if you notice, my gap used to go from here to here. Okay, well, sort of. So from -1 to +1, I like to joke and say mind the gap. What this did is it pulled my gap apart to go from -2 to +2. Okay, so it pulled everything away from the x-axis, which means that my gap is now twice as wide as it was a second ago, if that's helpful. So let's write out that range. That range changed to -infinity to -2. Pick it up again from 2 to infinity. Is there anything else that we needed to say on that one? No. So this was still, that was the same. This is still, okay. Just trying to indicate what didn't change and what does change with that transformation. Okay. On tangent, what I want to point out to you, we only, the way that I taught this, I didn't really give any coordinates. But you do know tangent values off of the unit circle. You knew, what I required you to know is that inflection point and asymptotes. So with this one, what we're going to do is we're going to, well, we know that this negative gives us a reflection. So instead of increasing, our graph will now decrease. But we're going to talk a little more. Also, what was at -1 right here, now it's going to get multiplied by -3, so that becomes a +3 up here. So let me get rid of this point. And then what was at +1 right here multiplied by -3 gives me a -3, and that's down here. Okay, and so we're looking at something like this. Okay, so it's been a bit of a stretch. I tend to, if I'm going to do a tangent or cotangent graph and I'm going to make you graph it by hand, I tend to keep, if it's a tangent of theta or whatever, g of theta equals or whatever it is, I tend to keep a just plus or minus 1 because I'm not overly concerned about all these details. And I haven't, what have I seen in PreCal? A lot of multiple choice. They're not going to make you graph it by hand. So, and what have I seen in IB? I have seen that if they want you to graph this by hand, which they might give you a grid. Okay, and so from that grid, then what I would do if I were you is look at this point, see what happens, and it goes up there, and you'll just graph it on the grid, and all is well. Does that make sense? Okay, but I tend to think that that stretch is kind of lame because it's hard to tell the difference. But the domain is still the same. The range is still the same. The period is still the same. There's still no amplitude. The asymptotes are still the same. All it did, well, we had a reflection, but we also had the stretch, but it's hard to see, and it doesn't change any of those details. And my midline, or my inflection points, are still the same. So they're still at y equals 0. The asymptotes are still theta equals pi over 2 plus pi k. The period is still pi. The range is still all reals. And the domain is still x, I lied, theta not equal to pi over 2 plus pi k. And there we go. Okay. Hopefully this is making sense. Let me know if you have questions, concerns, or comments. And we have one more variable that we need to talk about. And this one is, it's our b value, back from our graph, our equation. And what this does is this gives us a horizontal dilation by 1/2. So that means that it's going to bring everything in closer to the y-axis. So if this point right here, for example, comes in here, it shifts. It was at pi over 2, and now it's half of pi over 2, which is pi over 4. What was at pi comes in halfway. It's now pi over 2. Okay, I'm going to clean this mess up in just a second. But the better thing, or the way that we like to think about these with trig functions, is we use this b value, and we say that the new period. Oh, maybe I should have written it over here in this column, but whatever. The new period is equal to the parent function period divided by b. Okay, so, or we could say 1 over b times the parent function period. But I have just, after all the years of teaching, I have been writing it that way. So in particular, what's the parent function for cosine? It's 2 pi. So our new period is going to be 2 pi over b. What did we say our b value was? Our b value was 2. So we have 2 pi over 2. I have a new period of pi instead of 2 pi. So that means by pi, hang on, there's a dot here that's bothering me. By pi, I'm going to do everything I need to do. So, oh, wrong. What did I do wrong? Did everybody catch it? I should be all the way back up at the top. So by pi, I'm getting back here. So this is going to be 1 period. Well, what has to happen in between? I have halfway through, I'm all the way as low as I'm going to go. And then a quarter of the way I'm at my zeros. So let's do a few more of these points. Excuse me. Okay, it's kind of nice to have this grid. And so let's get some concavity correct. Notice it's concave down, then concave up, then concave down, and then concave up and concave down. And there we go. Did my domain change? No, it's still negative infinity to positive infinity. Did my range change? Nope, it's still -1 to 1. Did my period change? Yes, we talked about that. Amplitude, it's still 1. I still have no asymptotes. My midline is still y equals 0, but the location of my zeros did change. So we could say it was that 2 theta would be equal to, where does cosine have zeros? At pi over 2 plus pi k. If I multiply everybody by 1/2, then I get that theta is equal to pi over 4 plus pi over 2k. And that will show me where, so the first one here would be at pi over 4, then pi over 4, then 3 pi over 4, then 5 pi over 4. Let's check and see. Pi over 4, then 3 pi over 4, then 5 pi over 4, then 7 pi over 4, then 9 pi over 4. And this would help me find all of my new zeros. Super. Okay, we're almost there. I need to almost be there. So the next one, my b value is equal to 1/2. This is a horizontal dilation by a factor of 2. So the period is going to be 2 pi over b because secant has a period of 2 pi. So 2 pi divided by 1/2 means we're going to do 2 pi times 2 is 4 pi. So my period is now 4 pi. So that means that everything is stretching like crazy. Okay, here we go. This point stays the same, but the asymptote that was at, well, okay, let's do it this way too. Theta over 2, where were my asymptotes for secant? They're at pi over 2 plus pi k. So multiply everybody by 2, theta equals pi plus 2 pi k. So now I have an asymptote at pi. I have an asymptote at 3 pi, which is too far, and I'm going to have to answer that phone call. So like, subscribe, comment, and I'll finish this in the next video.